Hello, the session has not started yet.
And good afternoon, madam.
I was just ringing you to be here. I think you are muted, sir. Just check. Your system is might be muted.
Okay now?
No, no, it is okay now. So, should we start the session?
Yeah.
Hello, technical team.
Yes, shall I start?
Mhm.
Good afternoon to one and all. I am Purva Saxena. We welcome you all to IEEE INDICON 2020. With the depletion of Earth's ozone layer and the shortage of our oil supply becoming an issue, we have had to look at alternative fuel vehicles that will not harm the environment but will still provide us with a reliable source of transportation. Electric cars have been thought of as one answer to our dependence on fossil fuel burning vehicles as it operates on an electric motor instead of an internal combustion engine. One increasingly important segment in the EV market is light electric vehicles. In part, their attractiveness is due to their low initial outlay as well as their budget-friendly operational and maintenance cost. The whole world is working upon implementing IoT. ST Microelectronics, Infineon Technologies, Freescale, and NXP Semiconductor are four of the top five OE automotive semiconductor vendors. To guide us more upon electric vehicles and smart semiconductor lighting, here we have Dr. Aman Jha with us. He is working in ST Microelectronics since 2015 as power electronics designer role. In current role, he is associated with LED lighting based power converters for home lighting, street lighting, solar LED lighting and smart lighting. In this role, he has developed 7 evaluation on the ST web page, 24 other customized designs for the mass market, and several reputed international publications in the reputed journals. Recently, he is also associated with the e-mobility program and working for PMSM or BLDC motor control inverter design for electric vehicles applications. He has completed PhD from IIT Delhi in 2017 and MTech from IIT Bombay in 2005 in power electronics and electric machine control area.
Yes,
He has
completing
total
PhD from
15 years
IIT
of
Delhi
industrial
2017
experience
and
on
MTech
smart
from
switching
IIT
mode power
Bombay in
supply,
2005 in
product
power
design,
electronics.
control systems, stability analysis, automation, industrialization, power quality, high frequency magnetics, EMI, semiconductor power devices, and component selection. He has more than 45 reputed research publications in IEEE and equivalent journals and several free designs available on different technical forums. It's my great pleasure and honor to welcome Dr. Aman Jha to deliver a speech on the topic electric vehicles and smart semiconductor lighting. Over to you, sir.
Thank you, Purva. So I'm just sharing my presentation. Hope my slide is visible to everyone.
Yes, sir. Yes, sir.
Okay. Okay. Is it now in means visible mode?
Yes, sir. Yes, sir.
Yeah. Hope I'm audible and visible to everyone.
Yes, sir.
Okay. Okay. Good afternoon to all. Basically, INDICON organizing committee, especially Prerna ma'am and NSUT University and other of this talk. I am thankful to all participants investing time for this talk. And at last, not least, I am thankful to my organization, ST Microelectronics, for encouragement to participate such events. In start, I have taken a few slides from my company to understand each other better. So how to Purba, how to move slide here?
Sir, you can click on the right arrow button.
Right arrow button. Actually, I'm presenting for. Okay.
Sir, there is one
Okay, thank you,
option also
thank
down.
you, thank you.
Yeah.
ST is basically one of the largest semiconductor industry in its own domain, and its revenue is close to 10 billion USD. Probably more than 46,000 employee we have, on which around 15% working in R&D. So basically, our company is a global company. You can find us in entire globe. So these are the different locations for our presence. Where you can find us, basically, like smart city, smart drives, and a smart industry. So basically, if you see these are the end market to address for our chipsets. Major enablers basically smart mobility, power conversion, and the IoT, as already Purva said. So these are basically our enablers. If we see our work and the complete ecosystem, so we collaborate with product divisions of ST within company, R&D centers, different universities, and our customers to develop the system solution as well as basically using our chipsets and components. Now, basically coming to the topic, basically here topic is to design the EV inverter applications. So this is our agenda to talk for this tutorial. Basically, first we will see the how and why EV transmission is working basically and why it is taking momentum. For that, we will discuss about the motor is an integral part as a driving force for the vehicle. Then we will see the configuration of motors need to address electric vehicles. Slowly we move towards the control system of electric vehicle motors. In order to control motor as per the vehicle requirement, we will here discuss about the semiconductor components like power switching devices, gate drivers, operational amplifier, and the microcontroller as a brain to do such functionality as per need. In order to better use of all the components, basically, and the difficult mathematics that we do being electrical engineers to incorporate in microcontroller. Microcontroller is a low cost solution and it is now in upcoming area for the EV as well. So we will see the motor control software ecosystem for from our company side. As an example, here we will which we basically free to task to basically include our and question session at the end. So coming to the first part, this is the EV. What is basically this is the basic thing. So what is the EV transmission and control all about? If we see the go to the history of this, so as per literature, we can see the means how means as EV will progress. So new fuel with the battery and the electric charge could be the fuel, whose cost, as per expectation, it could be less. And as per the based on the as technology will progress, we will see the energy infra needs to be improved. Picture, if you see here, this picture I have taken just for the introduction part. This is the four-stroke engine that is still working for the all the means automotive domains. This is basically the modern gasoline engine, and it was invented 150 years ago. And it is basically, if you see the work, so most of the work is done by mechanical engineers in this domain. So if we just go to the just for the introduction part for the electronics people, so here on the first stroke, we will see the gasoline is injected into a chamber by opening a valve that is then closed again. On the second stroke, we will see the piston moves upwards and the gasoline is compressed. On the third stroke, the energy in the fuel is harvested by igniting it. The resulting explosion drives the cylinder basically down, and that produces a rotating motion. This is basically, if you compare where we push and pushing down and pedal moves and bicycle forward. And see at the fourth and the final stroke, the energy burn is immediate. This is all about the four-stroke engine. And by naming this, you can see the complexity of this. But if you just see the electric motor here, so this is basically we are thinking about the new engine, and here we are taking a coil. This just like a basically this is a coil and a wire and make electricity to flow through it. So it creates its own electric field between two magnets here in north and south. And basically we see, so one side of we push and the other we push down. This the coil turns until it is vertical. At that moment, we quickly change the polarity. So in this way, this works, and this is just a representation purpose. These are the picture of the electric motors. This we will see in means all the EVs. This will be as a engine. At that moment, we quickly see the means as per picture wise. This is look like a very simple things, and just for introduction purpose. Now, if we have to just compare electric motor versus heat engine, or we can say electric engine for the EV and heat engine for the current. So now coming to the first, just for technological comparison here. Here, electric motor is more suitable in terms of comparison with heat engine. You see here the all parameters like means kilowatt per kg, kilowatt per liter, as well as the efficiency and the moving parts, all are in favor of means electric motor as a electric basically EV for the EV. The picture here for the two engines. This is the very means looks very means low cost as well as size wise. It is good to use with. And this is for the heat engine, so this looks very complex. So where is the problem? So now coming to the important part here, the fuel tank of the EV system. This is the battery. This was the basically major blocking point for the EV to be progressed as of now. So being a power electronics area to work with, we should just understand the technology of the battery. There is no need to go in detail of this, but this is very important. This is basically, if we see the progression, 1900 to the 2025, this will be the energy watt hour per kg. In terms of the fossil fuel like gasoline, so we will see here, even in 2025, we will be 30 times lower. So future seems good. That is the lithium air battery. So lithium air battery is equivalent to the fossil fuel. So we will see, and these are basically predictions, and a lot of literatures and people are going through this kind of battery, and you can find a lot of literatures and articles for this battery. So we will not discuss on that. So, but now coming to the range part, the range connectivity, this is again important part for the EV. So if we simplify as we discussed in the last table, so if we simplify the last table, we can easily compare how much weight we need to bring in our car to get 500 kilometer extra range with each type of battery. For example, lead acid battery, we have to put elephant on your car equivalent weight. Similarly, for the lithium in 2025, that is the expectations for the 500 kilometer range, we have to put pig on your car. Part. So another parameter is the ownership cost. So if we discuss on any technology, so survival is very important to discuss. Here we are discussing the cost of ownership in terms of different sections. For example, drivetrain in electric vehicle is cheaper than the conventional. Here research is, as we discussed, is ongoing, but we hear prediction is in 2030 we will be come close to that. Now this section already is basically already we discussed different parts of the EV inside the vehicle. We are not discussing here charging part, and now coming to the motor. So here topic is EV motor is the major things. So here we will not discuss much on the design part of the motors because for the limitation of the time, we will just see which motor is useful to design a electric vehicle. We will here highlight the technology and requirement for the electric. So if we see, this is the just classification of different motors. AC IM means AC induction motor. PMSM, I think everyone knows, this is the permanent magnet synchronous motor. So these are the motors, basically electrical motors. And if we see here, efficiency, higher efficiency, starting from this to the reliability. But for EV, so here, these are the motors, highlighted motors is more useful. And but why, we will discuss here. Next. For selecting the right motors is a very important part. So the rating of the electric machines for use within a EV depends on the vehicle mass and the desired acceleration performance, as we read in mechanical books. So some general requirement of electric machines for the use within the electric vehicles are here. So basically electric machine design should be optimized so that the kinetic energy of the vehicle generates as much electrical power as possible and that the stored energy from the battery can be delivered to the road wheels as efficiently as possible. Here we will discuss about the EV motors for different and how basically EV motor differ from the industrial motors. Basically, in motors are in much use even from the 18th century. So how it is different? So here, as they basically we need here generally require high and low speed torque depends on the traffic conditions, road conditions. Here the enablers is the vehicle to meet the acceleration requirements. Another enablers and wide range of and operating speed is also very much required. In contrast, if we see here for the industrial motors, basically are generally optimized for a specific rated and rated conditions as well as the less dynamic operating conditions. So this is the just difference for the conventional motor versus the EV motor. If we go further, how we compare different motors. So here for the EV kind of applications, we can go for the three kinds of motors. That is the induction motor, that is also easy to controls, but that at the same time efficiency wise it is poor than the permanent magnet motor. And here we can see the three motors they call induction motors, permanent magnet motors, and switch reluctance motors. These are the only three motors is performance-wise useful for EV kind of application. In conclusion, if we see the different comparison parameters, so permanent magnet motors are the most suitable, and switch reluctance, or we can say synchronous reluctance motors, is in progress. So here most of the research is ongoing. Later we will see why synchronous or switch reluctance motor will be the future for the EV in the basic construction part. So this is the, if we see the motor torque and the speed plot, this is also the very basic plots, speed versus torque. So for the EV inverter designer point of view, here we can see as per this plot, electric machines to be characterized with respect to the speed range, constant torque range, and constant power range. As here if you see the at speeds above the base speeds, the torque decreases, resulting in a constant power. Performance parameters here we can examine here were based on acceleration, time, and the distance, and overtaking time and the distance. For high-speed cruising, for example, if we go for the cruising operations, it was generally found that the electric machines with higher extended range ratio, or means ratio of constant torque region to the constant power region, the acceleration time and distance to be increased. So this basically idea here is to, this seems easy, but we have to design your controller that can act according to this graph. So means for basically, as we discussed here, microcontroller or DSP could be the use case. So we have to develop your code software according to this plot. So that's the reason we are highlighting this. Now coming to the first motor, as we discussed here, that is the induction motor. I think everyone knows this. This is the lot of advantage, and disadvantage is limited here. So the why the induction motor is can be useful for this. Here we can discuss about because basically the magnetic field here produced by current that flow through the windings in the housing or the stator. Or if we connect the stator, so here now if you connect that stator to the alternating current, so this means the magnetic field in the stator will also alternate. So if a three-phase AC input is used, as so-called, we will get the rotating magnetic field. I think everyone knows what is a rotating magnetic field. So the magnetic field from the stator will basically induce a voltage and current in the winding of the rotor. So that is why it is called the induction motor. I think you go to the second year course, so the reason behind the naming of the induction motor is this in turn leads to the rotor producing its own magnetic field, and the magnetic field will make the rotor run to align itself with the rotor will follow this rotating, basically the rotating magnetic field in the stator without the need for the commutator with the brushes. So that's the reason this cost of this motor is less, but at the same time, the some problem with the efficiency. So now coming to the much popular motor, that is permanent magnet motor for the low speed vehicles. We can also name as a BLDC and brushless DC motors. So if we construct here, so idea here is to we are no longer need to induce magnetic field in the rotor, because here rotor is a permanent magnet. So because all these permanent magnet motors basically are currently the smallest and the lightest electric motor we can use, because the rotor is already magnetized here. It is always is synchronous with rotating magnetic fields. That is why some people also name it as a synchronous motor. And we will go further on the use case of this as well. Now coming to the important part, that is the synchronous reluctance motor, and advantage and disadvantage of and the popularity, and could be the future of the motor for the EV kind of application. Basically here it has a rotor that contains the metal, that is formed in such a way that it wants to align itself naturally to surrounding magnetic field. So here we will know there is no need to go for the permanent magnets. This means here it does not need to produce its own electric field through induced currents like the induction motor. That is the best case for the in between the induction motor as well as the permanent magnet motor. Finally, here there is no permanent magnets, so that makes it much cheaper than the permanent magnet motors. In conclusion, if you conclude here, so in conclusion, this could be the future, and more attentions are for this kind of motors for the EV kind of application. Now, as we set our battery, as we know the what kind of motors we are going to use, now where to put your motors in terms of the gravity and the motion. If you, as we are discussing here, the motor is basically the EV could be moves on the roads and a lot of different speeds and all that. So motor configuration is again important part to. So means here is idea is to which where to put the motors. If we see, this is the one kind of single motor configurations. So several motor we can discuss here different motor configurations. So for single motor configurations, we can see here motors and the power converter and the motor controllers. These are basically uh, three things, and if we see here, although if we in the transmission side, so this motor transmits either it could be front or rear wheel, and it could be dual configuration as well. And for the low cost kind of application, low speed vehicles like e-rickshaw and bikes, electric bikes, this kind of motor configuration is much. For dual motor configurations, two motors are used here to drive EV, and this can be done in different ways. Here you can see the motor controller, and that drives two power converters for the two different motors. Okay. So second, both the motors can be placed in either the front or rear axles, or it can be one also, depends on the torque requirements. At last, the four-wheel motor configuration for the high-speed drives. This is also the popular but complex. So this can be achieved using in-wheel like transmissions and motor inside the wheel. So this kind of configuration is for the high-speed electric vehicles, and this could be gear. Here we can put the gears as well, gearless options as well. So, but if as we discuss here the complexity side, so additional complexity and hardware requirements make such system more complex. But it is also in progressions, and people are thinking about this. Here again, the other parts we need to discuss here is the driving and the braking part. So, being in the mechanical field, so we will not discuss here the driving part and the braking part of the EV. But we need at a we set the battery and the motors. We have selected the motors and we set the motor configurations. Now the next part is to how to control. So EV control is the important part. Here our role is very important for being a power electronics designer. So this strategy we will discuss here. Basically, in popular, if we see in the market, normally 6-step and the field-oriented control kind of motor configuration means motor control is there for the PMSM. So here also we are limiting the control part. Basically, here we skip the induction motor control because it is not new things, as well as the SRM control technique, that is the limitation of the time for these presentations. So we will discuss here 6-step and the FOC for the PMSM BLDC. So coming to the 6-step control, what is the 6-step control? Basically, here two phases are always active. This is the diagram, and one is floating. Basically, there are 6 possible configurations, 6 states of the switch. So rotor positions are monitored using the Hall sensors or sensorless, depending on the requirements. And normally it is a low cost option. And if we see the lowest, all the low speed vehicles like and bikes mostly are this kind of motor and 6-step configuration. Okay. And for position monitoring, normally we will go for due to the cost limitations, sensorless kind of applications. And we will also go with the back EMF sensing and detecting the zero crossing for the voltage on the floating. So this is all about means 6-step controls. But how to implement this? For that, I have taken just one. Just a minute. Okay. So uh, 6-step block diagram, if we see. So I have just taken an example as a STM32 as a core for this. So here, this will be the block diagram of that. So here we can use a power bridge, gate drivers, current sensors, speed sensors, and this will be the complete block set of the 6-step block diagram. So any microcontroller can be used, but we have to think about these are the possibility: ramp generations, PID, zero crossing detections, and these are the basically concept need to be inside the microcontrollers. As well as we will discuss about the different next section, we will discuss about the different chipsets for the gate drivers, current sensors. For example, here if we go for the single sense, 3 sense, depends on the requirements. Speed sensors. So basically, this is a just a block diagram of this. And if we go to the means 6-step means for the plotting part. So if we see the current plot, this will be the 6-step control, basically the pulse. And this is mostly if we see the in the market, so mostly it is used in the electric rickshaw, electric cycle kind of applications, and it is a low cost and much popular in the low speed vehicle market. Coming to the next part, that is the FOC, field oriented control. So this is mostly used in means relatively high speed vehicles. So here, as we know, the field oriented control FOC, here in our books, a lot of mathematics behind this scheme. So normally we read in these things in our courses. So we will not go in the detail of the mathematics part. We will see how to implement those math part inside the means code or inside your product development. So for that, we will see the just a block diagram. So which kind of sensing we are going for? Either we can go with either free shunt, single shunt, and ICS means insulated current sensing. So like Hall sensor kind of thing. Similarly, we have to think about the speed position sensing. Basically, it is mandatory. It could be encoder, it could be Hall or sensorless. So current controller, we have to go either with PI, D, means, and these are just block sets. So basically, idea here is to just show the means a basic block diagram of means field oriented control for PMSM motor. So now we can see the actual block diagram. So this is the block diagram of FOC implementation using STM32 microcontroller. Normally, our microcontroller F3 and G series microcontroller are available in the market. There, all the mathematics can run inside the MCU. So we need to go with an implementation part and start designing our codes using such kind of microcontroller, even not in ST, other microcontroller also available in the market. But we have to think about those mathematics. Is it inbuilt or is it working or not? For example, MTPA, flux weakening, a maximum torque per ampere means, and flux weakening means is also needed for the extended range of the speeds. These things we can go through inside the book, means requirement and a specification part of the EV applications. Here, see very social way see for it, but calculation is complex. As we know, the mathematics, lot of mathematics is there, and so we are getting good benefits. But of course, we have to go with more control environments. So sensing and PCB designs and other things are very important to work with this kind of application. Now, as we know the control part, then we are going for the power devices. Again, this is a very important part, which devices we have to select with, and we have to go for the EV inverter design. So from here onwards, we discuss EV inverter. The first device is basically we know the switch, that could be the IGBT or the MOSFET. That is normally, and here again we have to limit, because depending on the market and depending on the device available in the market. Here our presentation is limited to the 10 kilowatt kind of electric vehicle applications. And the battery system is also very important. Before designing your EV, we have to know which battery we are working for. So here we are limiting the battery voltage up to 22 volt. So these are just recommendations. So and for that, now here coming in this section, we are discussing about the MOSFET. So these are just basic things to selecting the right MOSFET, because the right MOSFET is very important to select. It will decide your efficiency. And here we discuss about the new, basically idea here is to low RDSO on, as well as the switching low QRR. So these are the major parameter figure. It is also known as the figure of merits. So for example, if you see here, the RDSO on multiplied by QG, that is known as the figure of merit. So we should not only see the RDSO on value, we have to also check what is the QG, as well as the low input capacitance. As we discussed here, a lot of is there. So we have to also see what kind of CRSS and CSS are there. So this is the reason we have the one series of the MOSFET, that is the F7, but this is from the ST, similarly from other companies. So idea here is to give the selection part to select the right MOSFET. For the low, basically, similarly for higher voltage. So these are the list of the MOSFETs available in the market. And ST says different names like M6, DM2, and different K5 series for the different market, like power energy, servers, industrial, car electrification, as we are discussing here. So these are the different MOSFETs, and we have the basic theme is that, so speed and loss, basically RDSO on is the middle. Other enablers for the industrial and automotive are basically super junction technology. Here also we need to be careful in selection of right switch. So other parameter, basically, as we set the switch, now we are discussing about the gate driver part. So now gate driver portfolio, which needed to drive switch reliably. As we know, just designing the gate driver using analog circuits will create a lot of issue. So gate drivers is very important part for EV kind of application, because this is a very noisy environment. So the right selection of gate driver is important part. So these are the, basically, if we see that these are the different gate drivers available in the ST portfolio. So we have to think about the similar gate drivers for designing our EV inverters. So this is just a one gate driver, that is a 600 volt kind of half bridge gate drivers. Here 6491 gate is named as a 6491. This is very much popular in the EV inverter kind of applications. This is because here we get the very good noise immunity protections, as well as smart shutdown features. And the when your design will progress. So before designing your boards, we have to also think about the validation part. So for validating your gate drivers and switch, these are few boards also available in the market to start the designs. This is another kind of gate driver. So this is the 600 volt triple gate driver. So one gate driver can do all the six functionality, means because here basically six MOSFETs are there. So one gate driver can solve your all problems. So low cost of EV inverters, such gate driver can be used. Similarly, this is the another isolated gate drivers. This is known as ST gap 2S, and these are the some benefits we can think about. This is another kind of gate drivers. Now coming to the op-amp part, because here, as we know, the current will increase and the measurement part, so we need some operational amplifier to do the fast current measurement. So again, this selection part is also very important. So here we are highlighting the motor control for correct balancing of the current as per the branch needs. Here three different branches. So we have to go in detail of the selecting the right operational amplifier that will give the correct current value and correct measurements. So because we need to, if we go further, so because we have to go with zero drift in temperature, as well as temperature will also increase, depends on the means time and speed of the vehicle. So this is one operational amplifier, but we can find out the similar kind of things and we understand why this is can be used or not. So this is again engineering work. And for the high side current control, this is another kind of operational amplifier to control current going to the motor. Idea here is to control the current that goes inside the motor, use the voltage loop drop on the MOSFET, which ensures reverse battery protections and also the low side current measurement. This is another kind of high resolution kind of operational amplifier. Similarly, for the for other PWM feedback comparator, this is also useful to start the design. These are the few others, and the analog sensors kind of amplifier. Now coming to the STM32 based MCU for the motor control. If we see the ST, as we know, the ST is the top 5 semiconductor company, and we have also very large portfolio of the microcontrollers. So these are the market heading slides for the different microcontroller. But we will go with here we are discussing motor control. So we will go and actual which kind of microcontroller has to be selected for the EV inverter. So for the designing part, so these are our ecosystem. So we have a lot of MOOCs available in the literatures. So for designing, we have a lot of hardware, software supports available, and the IDE support also. We have also free IDE for the customers, like that name as Atomic. So as your design will progress, you can follow this web page and design the correct code. So for the MCU selection part, if we see, these are the different microcontroller series for the EV kind of application. For example, if you are going for the 1 cent or 3 cent, we will not discuss why 1 cent, why 3 cent, but as you study the things, so these are basically parameters for the EV inverter kind of application or any motor control also, but here we are focusing on EV inverter. So current sensing and overcurrent protections, speed and position sensing, bus voltage sensing, because bus voltage here is the battery voltage, under voltage protections as battery discharge. So we should have under voltage protection, over voltage protection. Similarly, we need temperature sensings, over temperatures, field oriented controls, as we discussed, and the control mode. Which kind of control mode? Torque, speed, positions. Other features like maximum torque per ampere, flux weakening, feed forward. These are the parameters we have to monitor. So I think if we go for the embedded designs, we have to make the our means flow chart and input or output kind of things. So depending on that, we have to select the right micro. Series has everything, but we have to choose depends on the cost and depends on the requirement and depends on the vehicle. So this is just a chart to understand which microcontroller can be used for particular specific EV inverter. So for that, basically we have a system solution and motor control software kit environment. Basically, normally power electronics people are good at hardware. So for that, we have developed one MC SDK environment. So here we will discuss system solution and work to go for. Basically, few solutions like this design is for 250 watt 36 volt electric cycle controller. This design here we have implemented field oriented control, and it shows the capability of these devices. And if someone knows want to go and design of this, so they can find out this kind of boards. This is another designs. It is also available in our web page st.com. So and this design, this is for 5 kilowatt 48 volt low voltage high current PMSM motor drives. This design is STWell, and STWell this code is also available on the st.com. These are some features. It is for industrial motor drive and traction inverter kind of applications, and it operates on the FOC. We will not go much in detail of this design. So this design is for automotive markets. So automotive, we have also automotive MCU, that is SPC5 series, and this design is also available for designing, starting the design. And it means people can follow or engineers can go with. So in order to start the development in this environment, we need to start embedded software as well as hardware together. There is need to download MC SDK from the st.com. This is the link for that, and it is basically freely available design and start working with available designs. Some designs are also available on there. These are the designs available. If someone is good at software part, they can use this design directly and develop their codes. So for that guidelines, this application note is also available there. And they can load their projects. This is just a picture of that. So different codes menu and start their works. Similarly, we have the library of that for in all the block sets. For example, speed and position feedback block sets, speed, all the parameters, different blocks are there. So depending on the use case and how to use. Also, it is written in the 2392 application notes user manual. Coming to at the end, so as we discussed here, as electric vehicle is upcoming technology, I think there is no doubt on it. So we have to designing EV inverters is important parts. For that, we need to understand the battery and the motors, as well as the where to put it, that is the motor configurations and drivetrain need to work with. As well as we also need to understand the electronic part. Electronic part means electronic components means the MOSFETs, right gate drivers, microcontrollers, and other means switches. And basically, it will affect your cost. So our effect will be the system cost of your electronic boards or motor controllers. So it is very important part. So we have to think about it, and depends on the specification. This is very important things. Then as we your design will progress and you know the work with, so some solutions, system solution from the semiconductor company will help to understood to reach basically your goal in shortest possible times. So sometimes ready-made solution available, it will match your requirement as well. So it will also save the development time. And the motor control environment also basically it will help you to develop your embedded code in a shortest possible time and easily implementable without knowing much on the embedded C or embedded code. So these are basically the part for the EV inverter design. So thank you. So any questions?
Audience, if you have some questions, you can ask Dr. Aman Jha.
Good evening, sir.
Good evening.
Sir, I want to ask a question.
Please, yeah.
Sir, to reduce the charging time, phones like Asus, ROG, and Lenovo have divided the single battery into separate batteries. Thus, the phone is having two charging ports and charging time drastically reduced. Can this approach be applied in EVs to reduce the charging time?
Basically, right now we are discussing on design. So basically, charging things charge. So in if we go in detail of the EV chargers, so three kind of chargers are available in the market because EV is the automotive things and the
Yes, sir.
mobiles is the basically industrial things.
Yes, sir.
So for automotive, we have to follow the guidelines. So there is, if we go in literature, so there are type 1, type 2, and basically CDMO charger that you are talking about, the fast chargers. So depends on the requirements. So definitely you are, maybe that could be the inside the core that will be there. But we have to think about it. So we have to follow the guidelines, and like if you go in the CDMO chargers, that will charge your battery in 30 minutes, and that are the norms. It could be inside that, and definitely it could be. Yeah, please.
Thank you, sir.
Hope I answered your questions.
Yes, sir. Thanks a lot.
So I will next start the lighting, means LED lighting presentations. Any question from audience? Hope my screen is visible to everyone.
Yes, sir.
Okay. So basically, design part we have to basically, if we conclude means EV inverter design. So for EV inverter design, input could be the battery. So right selection of the battery is very important. Which battery we are going with? what could be your extended speed range. So after you have selected your right battery, then the next thing is to select the right motor. So motor again, as we discussed, three kind of motor is basically induction motor and SRM as well as PMSM. These three motors are applicable for EV domains and depends on the use case. If you see in the literature, some motors are also work on the mixed mode and motor selections and where you have to place your motor. That is then again another point, and how many motors you are talking for. For example, if you are working for the dual configuration or for motor configurations, depending on that, we have to design the motor controller. Then if you have decided the motors, if motor only one or two, if your decision is either go with dual motor configuration or single motor configuration with the level battery, then the next item is to design a right inverter. The right inverter design, we have to go with switch, like either you can rely on the MOSFET or IGBT, depends on the voltage and the current requirement. Then the driving the motors, then the microcontrollers to control the, if either you are working for the 6-step or the field oriented control, OC. So for that, either we have to go with current sensing and position sensing is very important, because if you have selected the PMSM motor, so these 2 points is very important. If you are going with PMSM motor and you are sure you are going with ICS kind of means insulated current sensing, then the MOSFET microcontroller is very important, because microcontroller is low cost option. So in that way, we have to develop your schematic, then you have to develop your PCB and then test it. So this is the overall inverter design. Then you have to put everything in your car or your vehicle. It depends on your requirement, like e-rickshaw, what kind of EV you are talking. It could be electric boat and anything. So this is the complete ecosystem of the EV inverter design. For that, you have to understand the coding part, PCB design part, hardware designing part, and at the end, you have your complete design will be complete. So this is all about the EV inverter design. Okay, anything? I think this is okay.
So very detailed talk as with regard to controllers for these drives you have covered, and also LED lighting, smart semiconductor lighting. So I hope the participants have immensely and got all the information regarding all these things. So the technical team, you may now conclude this session by thanking Dr. Aman Jha.
I would like to thank you, sir, on behalf of everyone present here at INDICON 2020 for sharing your words with us. Thank you.
Thank you.
Thank you, Dr. Aman Jha. Thank you so much.
Thank you so much.
So should I start the lighting part?
Yes, sir. Yes.
Yes, sir.
So maybe at the end of the lecture, maybe everyone is exhausted.
Yes, sir. No, these are very enlightening talks. They are ready to listen to for long hours today. They were waiting for this event. Yes, sir.
Because in 1 hour, very difficult to discuss complete design, because projects are
Yeah, I know.
EV inverter projects could be for 2 years, 3 years kind of.
Yeah,
times.
yeah, yeah. Actually, you're detailing. You might be knowing when students will work on these systems, they will then recognize what you have given this information in 1 hour to them.
Because this is for 4-5 engineering teams is needed,
I know.
basically for PCB design and
Mhm.
mechanical team,
Yes,
hardware
yes,
team,
yes.
software team.
Mhm.
So coming to the smart semiconductor lighting, basically this is the LED lighting we are talking for. So basically this is our outline of this talk. We will see here the market potential in the LED domain. Then we will discuss about the LED as a light source and the design behind it, and the behavior of LED as a load for the power electronics engineer. Because for power electronics, earlier we have CFL, now we are talking for the LED. Then we will see here the solution for engineers for different LED drivers, types, topologies, and configurations, etc. After that, this we will discuss on a smart LED light that could be for IoT application. In this section, we discuss on system solution developed by here in Noida team. That is the basically our presentation part. So at the end, this we will see more solutions in similar domain to understand the smart LED light better. We will also see here our real-time deployment in our campus, here Noida campus, in this domain, which operates here reliably in last few years. At last, we will conclude the current trends in this domain. As for researchers, they can go with for further, and at last we will see the question answer part. So in this section, the section we will see the LED products and very popular everywhere now. Entire lighting domain, everywhere lighting LED is there. Even EV is not present, but lighting is there everywhere. So that's the reason people are not talking on lighting, because it is LED is the means EV is the future. So these are basically the product available in the market. It is easy to understand with. Now coming to the market price. So globally, basically, we see the market potential. We grow by LED will grow by 14%. For the Grand Service Sage, LED market will be close to 154 billion USD by 2024. So basically, it means 2027, not 2027 this year. So the smart LED lighting market, smart lighting means here lighting will works as of own. So it will grow by more because it is new things. So 18% in the same period as per the market and market consulting. So the overall market for the smart light was close to 14 billion USD into 2019. 20 will see the 31 billion USD. This is the big market, and maybe this year there will be a drop due to the COVID. We will see the result. So again, if we drill down the business further, the LED light use case for different products, this is the data. So here, general illumination covers around 23% of market. General illumination means the lighting that we use in our home, street, and everywhere. The major focus here, our discussion is the general illumination. We will not go in backlightings, TVs, monitors, other kind of lights, that is signage kind of thing. We will here discuss about the general illumination to make our life simple. So LED as a light source. In this section, we can see if we go to the history part. So the physics, if we see the light is started with the heating of the filament in 1880. That is we know that is we named as the incandescent lamp, and later it is improved with the next evolution. If we see here in the market, next evolution will be in 1950 by generating light source using the gas the CFL and the induction. Discharge techniques of light source enjoyed till 2000 due to the better light output and efficiency relative to the heating filament. In the start of 2000, there was the invention of the blue LED. Everyone knows by Nishia, Japan. There is the Nobel Prize winner as well, which opened door for the LED as a lighting source. It is basically fundamentally a solid state light. That is the topic, semiconductor lighting, and it operates on the recombination of electrons and holes. Earlier, it was not there. So right side the picture, if you see, basically next milestone, which we are thinking about the AI or machine learning will come into picture in the lighting. Being in the large volume presence at most of the places, because light is everywhere. It could be the use case, obvious use case for the AI and ML. Why we are talking about the LED light? So as we know, these are the long list of advantages and limitations are very less. Long life, better light quality, efficacy. We will not go in detail of this. But if we go to inside the physics part, if we see the fundamental behavior of electrical engineer point of view, it is a non-linear electric load. A small change, if you see here this graph, a small change in the voltage will create large change in the current. So for power electronics people, designers, we have to design your power supply that will act according to that. Again, here for different colors, different the waveforms. So we should know, and our design should know, and our power converter should know this kind of graph, and it will work according to that. Because if it will create large change in the current, being a semiconductor, LED will fail, and your entire light will fail. And our claim, like as we said, long lifetime will be compromised. This is the reason we are being a power engineers or electrical engineers. Our work is to run LED reliably. So here we will discuss about the different driver types, and as we know, what is the drivers. This is the LED driver complete block diagram. As we discussed already, being a DC, fundamentally DC and non-linear nature of VI plot, LED needs a specialized driver to run it reliably. The life of LED basically justified to be long if your driver will support to that extent. As we said, 1 lakhs hour of life, but if your driver will work less than that, then the life of a lighting system will be less. So this is the LED driver complete block set. For regulatory need, input filter here for regulation needs input filter that will depends on the safety and EMI and EMC. So we have to for reliable power here as per LED load DC-DC converter here DC-DC converter is selected, and these two displacement PFC and input filter is as per the regulations requirements, and DC-DC converter is the lighting requirement. So this is the power system. This is for power system requirement, and this is for power conversions load requirements. So for control these two, we have to go on either analog or digital power electronics systems. So it could be analog as well as the digital. Depends on the different chipsets available and the microcontroller available. We have to think about it. We can use one microcontroller for all these two, and for the LED side, either could be dimmings. We have to go with LED control system. Again, here digital, analog, microcontroller, FPGA, DSP depends on the use. LED in the market, if you see the different companies like Osram, Isuro, Classy, these are different companies. So here means material science, and here electronics engineers has to work. So going further, so as LED technology is progressed, we need to classify your drivers to understand it better. So LED driver here you can classify based on the power ratings, output voltage, input supply, isolations. Power output voltage means it could be lower than 50 volt, higher than 50. This is because as per the SCLV norms, safety extra low voltage, it could be less than 60 volt. So here this is the classification. Similarly for isolation, again safety requirements. For the input supply for the automotive or solar DC voltage, and for the normal this will be AC voltage. Like home lighting less than 25 watt, medium means street lighting, high power means stadium and all. So these are just a basic classification. This is very important because your power converter is also dependent on the power ratings, output voltage, input supply, and isolation. That's the reason this is the division part. Now coming to the PFC controller color classifications, here we have to again classify which PFC controller depends on the cost and efficiency as well as the regulations. These are the PFC controller used for the LED drivers. Like, for example, here we are used to energy storage elements. So it could be complete energy transfers on every cycles. It could be continuous conduction mode, depends on the loads, or advanced PFC. It could be multi-mode, bridgeless PFC, interleaves. These are just a classification. But in market, if you see, most of the LED drivers available is complete works on complete energy transfer mode, current mode, and voltage mode. Few are bridgeless PFC, but you should know the different schemes. So again, further, we have to classify in terms of the schemes. So these are the which we and we have done in our IIT Delhi lab for the PhD project. So these are the just tested converters, the labs, but depends on the use case you and the cost with benefit analysis you can work with. But you should know these are the scheme classification. So further, if you have to classify in means overall system. So depending on cost wise and power wise, less than 100 watt, we have to go with single stage. Single stage means everything in a one go. So these are much popular in the market. Similarly, for the more critical requirement, multi-string kind of two-stage drivers, it is for TVs or some other kind of applications. CRI means color index. CCT is correlated color temperature. Color rendering index means your if you put your object in your light, so what could be their originality of the color, and the correlated color temperature. These are the physical parameters. Correlated color temperature means what is your feel inside the light. If you are in the means a particular light, what is your feeling? So these two parameters, cool lights, warm lights, those are under CCT, and CRI means color rendering index. So normally for incandescent light, CRI is 100, and CCT is again another parameters. So these are the lighting parameters for the lumen engineers. Now quickly coming to the basically the topic of our presentation. Here, our focus is on a smart LED lighting or a smart semiconductor lighting for general illumination kind of application. So what we say, smarts. So in this domain here, attention for low cost, large volume market. As we initially discussed, it is the general illuminations. For block diagram point of view, LED driver will be integrated with microcontroller and communication interface to make lighting system. Here, this is the complete ecosystem of smart light. Here you can see the power management systems, microcontroller, and wireless models. Then you put your complete lighting system to the gateway, then the IoT cloud. So this is the complete ecosystem of smart lighting for IoT environment. So the communication could be here could be wireless or wired, depends on the cost benefit analysis as well as per user needs. For wireless, Bluetooth and sub gigahertz is the low cost, free option. There is no user charge. But at the same time, we have to compromise with the range. For the wide, DALI, digital addressable lighting interface, and power line communication can be used. For next level of smartness, gateway must be made and data can be stored at IoT cloud. So if we go in the ST perspective, here we have solution for wide as well as the wireless. This is the link here to go for further in detail. The right side here you can see the low cost similar solution developed by us. Here we will not focus on wireless technology because that is a separate field and that is not our scope of the presentations. But we will just discuss about the understanding purpose. These are the wireless network can be used as per flexibility, and here use this comparison in terms of data rate and distance. Again, here also we cannot go in detail of each because due to the time limitation, but we have here understand the sub gigahertz BLE, LoRa, Sigfox, NFC. These are the much popular in the market for the smart light. In order to explain our design in detail, this is the electronic board that is known as STL LLL06B1, developed by us in our lab, and it is available on st.com. So here even papers as well as the links are available for this board. The complete design and related collaterals also available on st.com to start in design of the smart light. Here board is working for wide range input 90 volt to 305 volt and wide range of LED load starting from 60 volt to 110 volts. As we discussed here, the voltage is a main problem with LED, means regulated voltage needed as well as the constant current. So this operates on constant current, the variable voltage. Whatever the LED you put up to this range, it will regulate your LED up to 700 milliamps. That is all about the LED driver will do this. Again, here the power quality parameters are matching as per the IEC 61032 class C is mandatory as per international norms. So we have to basically this is for harmonics, and we have to follow as well as we discuss here. This is a smart part. So energy star norms is again coming into picture. So it will control the consumption in daytime. Light will be there should be no loss. We have to follow the star region. The board operates less than 0.5 watts. So even in standby conditions. The constant current accuracy here you can see as we discussed. This is for 1%, and which is nice to have the idea of the controllability of the power. And overall efficiency again you see here 90% without considering auxiliary power supply. Auxiliary power supply here is just for BLE means module, wireless module for and microcontrollers. These capabilities basically are achieved by using our standard part here LED in LED domain that is known as HV LED 001A or 1V, different but not limited to this. You can use any quasi-resonant PFC as well as DC-DC converter in the market, and a lot of chipsets are available. So, so this is the all about this design. So in again, as we discussed, the range issue with here we are using sub gigahertz. So for the range limitation, here we are working on mesh networking. Basically, what is mesh network? Normally, much in detail of this. Mesh networking means basically one nodes connect with others, and in that way it will create a complete mesh. So we can extend the wireless range from 100 meter up to several. So this is all about the mesh technology. We will not go much detail of the mesh, but here we have implemented 6 low pan mesh networking for this design to for the improve the range. Complete design of this board for the electronic engineer's point of view. This is the complete block diagram of this. So diagram here clearly indicates how power management IC, basically this is your power management IC, controller is capable to work in self-start mode with single stage, single switch capability. Means here we are using only one switch and we controlling the, if it means LED current as well as the PFC. So this is a single stage single switch converter, and it operates in quasi-resonant mode. So efficiency is more. I think quasi-resonant mode people know. Quasi-resonant mode means there is two modes. Basically, if we what is the condition of this switch? So if your switch is on, means energy is stored in the your inductor, that is a flyback converter, and when your switch is off, that energy will be transferred. So on and off condition, it will create major loss because your efficiency, basically switching frequency is more. So here these two conditions can be made for the efficiency part. So if you save your energy in either on condition or off condition. So this IC basically chipsets do work on peak current mode. Peak current mode means when current will increase more than this current limits, then this will create switch off. And when switch is on, then when the complete energy is transferred to that, that will create a quasi-resonant or zero voltage detection things. Then switch will be. So in that way, this IC will do quasi-resonant peak current mode controller, and it helps and improve the efficiency. So this is all about, again, for the constant current, we have used here op-amp, that is high precision dual operational amplifier. It will do the constant current, and it will work from 60 volt to 110 volt. So any LED can operate from this volt to this range, and we will get also current feedback. The listens. Again, from the smart part, here the wiper section is used for the auxiliary power supply for the microcontroller and sub gigahertz. And the microcontroller L07 series is used because L0 is low power series, and wireless model is there. So this is complete overall design of this, and it is also available on the web. If you go to the major onboard components, these are the different components available on this board. So these are different, basically, different power components and passive components. Again, here, this is the transformer. Again, we will discuss on the how to design the right transformer. Now, coming to the different section wise, if we discuss here different block set, this section here we will discuss for the line and safety components. These are the basically works according to the IEC norms, and EMI EMC is 6/15, EN 55015, FCC Part 18. This will is regulated by, as I said initially, so regulation is very important. So depending on that, this section we have to select. These are the different components are selected for that purpose. For harmonics, IC 61032 class C and the primary active switch selections. Here, right selection of the MOSFET. This mathematics will see what MOSFET switch will be, as well as the current, how much maximum voltage. So here I have selected this micro MOSFET P21N90K5. So it is 900 volt MOSFET. So if we see here, it is well within the range, because maximum voltage, even if we see the leakage inductance into picture, again, a lot of margin is there. As well as the peak current is 5.18. Again, here current is, if I take this value, so the thermal capability will be better. So in that way, this part is designed. So again, for current sensing, as we discussed, current sensing and the current catch diodes, so output diode selections, this calculation will see. So here we have selected STTS 3L06, 600 diodes and the 3 ampere diodes. So this is ultra fast diode, and because ultra fast is needed because the switching frequency is starting from 33 kilohertz to 20 kilohertz, depends on the input voltage and the power requirements. So here also sensing current. This, in that way we select the right means this feedback going to the op-amp here. This is the op-amp. So in that way we regulate the current, LED current, secondary feedback control loop. This is the complete feedback control loop. So again, if we have to go with auxiliary power supply of HVLED, means basically that IC also need power. So this is just analog power supply implementation for that. This is without LDO. Normally LDO also inside the chip regulator, but we have implemented this here. But here this is cost wise, this is less. So magnetic design parts, here it is very important to design the right magnetics here. So the efficiency of converter is very much dependent on the right design of the basically transformer. Here selection of core as well as winding orientation is very important. The interleaved winding is good for tight coupling and better efficiency. The design value and orientation of winding of transformer is given here. Here I have restricted the detailed mathematics as well as other complex transfer function and simulation part to take basically to make our discussion smooth in given time. So we have here belief on our data sheet, and the solution results are coming as per expectation. So this book is also very helpful to design the right mathematics. So this is the and these results basically says the stability of board in steady state conditions. This is the steady state condition. This is the switching state condition. So here you can see the even this is at 230 volts. So a lot of margins for the voltage and quasi-resonant mode active switch on condition that I said earlier. So this will help to increase higher efficiency, and maximum switch stress would be here. So we have to design your MOSFET voltage up to this level, as well as the peak current will be up. And this will ensure the zero current detection in envelope of the ZCD. And the protection part, our LED driver is protected from the open circuit. Sometimes LED will fail, but your power supply will protect it. And LED short. Sometimes your load will be short, so but still your power supply will work. So this is the test result of. And the smart features, as we discussed, LED on. This signal is the dimming. This is the LED off signal, and this is your actual currents. Again, as I discussed, standby consumption at full load condition is less than 0.5. Again, in steady state, you can see here the overall efficiency, including wiper, means the auxiliary power section, we have better than basically even at lowest voltage, it is more than 85%. As well as the current regulation is very much regulated, it is less than 0.3%. So in power factor and THD, and here THD is very much controlled and the power factor is more than 0.95 for different LED voltage. Again, this is the very for the dimming functionality. So here we dimmed the light for the current from 0.7 ampere to 0.1 ampere. So as well as the power level. So same driver can work starting from the 10 watt up to the full 80 watt. So the thermal graph, it will clearly show the board is thermally stable. This picture is captured from the Fluke thermal camera. Again, according to the IEC norms, we have to match IEC regulation limits versus the actual board emission. So this is well within the range. Again, for the EMI/EMC, for the lighting products, CISPR 15 and EN 55015 norms. So here the EMC, EMI is well within. Okay. So few more examples are there. Like this is the two-stage high efficiency smart LED drivers. Just for introduction part, it is also available on st.com. So this is slightly higher power range, and it can be also could be the candidate for the design further for the new design perspective. Lighting with LED connectivity, and here we have designed this board for the home lighting kind of application. As we discussed, also we have deployed some lights in our campus to see the reliability of this. So here this is a smart hybrid solar street light installed in our campus here. So this will work basically solar lighting, and it is also IoT. It operates from on AC as well as the battery, depends on the availability, and it is completely automatic. And we have the papers and details also available the web. Again, this is the just picture of our installation. Deployment that is operates on the power line communication. This is another area for power electronics engineers. PLC, power line communication. Smart lighting operates on the PLC. We have G3 PLC control unit, and it is also installed on our campus. Now, quickly going to the key trends, and that is the new things will be coming in the lighting industry. So in this slide, we will just highlight there is, I think there is no doubt on LED, which will be the completely cover entire visual domain. The progression will be in terms of light quality, lifetime, size, and thermal parameters. So LED driver will be the judge based on the light, size, cost, power quality, and use case. As we know, the wide bandgap devices is will picking up, and we will see in future GaN will be make more compactness with high efficiency for the LED lighting, LED drivers basically. Other trends we will see our the smart side are AI, basically artificial intelligence use case. As we know, why LED is late for the IoT, because LED is the new kind of light source. So LEDification is the first target, then IoT application. That basically that created slow AI implementation for the lighting industry. But there is the basically huge opportunity at hand, as plenty of luminaries are still only switchable and dumped basically rather than intelligent. So having the data, basically having more data will turn the focus of design onto the people that occupy the building. If you see the, as we know, the AI could be use case for anything. So lighting system will be the best case because it is too many places it is there. So basically, the next boom will be for the AI-based lighting system that can optimize and tune the light parameter. As we said, the CRI and CCT, that kind of thing can be optimized using AI as the life of the light will progress. So and that will also impact the well-being as per new literature. A lot of papers on this domain coming into picture for the LED for the AI implement. So thank you for your time. Any questions on this part?
Hello, anyone? If you have the questions on smart LED, you can ask the questions from Dr. Aman Jha. Subhalakshmi, you are attendee. You are in the attendees list. Rashmi madam, you are there. You can ask your question. You can ask your question by typing.
Maybe in later you can
Yes,
drop me.
actually, Industry Academia Connect is possible this way only. And nowadays, education system is such that they don't understand what is going on in industry, and industry don't understand what is going on in academia. So this is the platform where two are connected. And whatever you have given this information to them, this they will understand after 3-4 years of working in industry. But it should be known at this level only, so that they will be useful just after their degree in any company. So this is lacking behind these things in India. So I hope that slowly this gap will be covered up.
Yeah, that is more useful for us.
Yeah. Yes.
Something.
Rashmi madam is asking, can students work, can do some projects in it?
That's the reason I share the slides so they can start literature things, and these are the implementation is coming in the market. So the street lights, home For
So
street
how
lights,
the
home
students
lights,
can
they
approach how the students can approach to do some projects on these electrical vehicle as well as on smart LEDs.
depends on the student's interest, because someone embedded and interested to work on embedded side, so they can
Mhm.
work on the STM32 ecosystem.
Okay.
If some are good interested to work with, because this is not a one people. So if someone are good at
Mhm.
hardware side and interested to work in hardware, so they
Mhm.
can start using basic design and start their first for literature, then go for their new designs.
Mhm.
Means
No, no. How ST microelectronics will help them to do some good quality projects so that they can cover up the gap between industry and academia, so that they can understand the things better during their BTech only or MTech or
basically
PhD.
yeah, we can share our, we have University Connect program here in
Okay.
ST. So
Mhm.
on that forum we can, I think there are other presentation also there in NSU, your university from the ST
Mhm.
side. So that forum could be the help. And even we have the boards
Which program you're
set up.
talking about?
uh, University Direction Program, University Connect.
Okay, so
In that way, I think even the intern ST from
Mhm.
the means NSIT,
Mhm. For
and
internship,
if
you conduct
someone
interviews,
interested,
no?
yeah, that's the interview basis. But those work are inside our campus and outside also.
Okay.
Unicorn.
Those microcontrollers which you have referred in this talk, can we get some training? Our students can get some training so that they can start working on it.
Yeah. That's the way of working, because someone are working microcontroller. There is a
Mm-hmm.
separate training for the microcontroller part. So this
Okay.
is just the overview and kind of a complete design and complete ecosystem. So
Mm-hmm.
it can be make piece wise, and that can be developed. Student
So
development can be
how
done.
how someone can approach for training part and for internship part?
I will check with our means that department HR, and then I will let you know.
Mm-hmm. And how IIT Delhi is connected with ST Microelectronics for electrical vehicles? Sir, I would like to understand the things so that we can also start developing such ecosystem here.
In similar way, there is the connection there, and
Mm-hmm.
there is no any specific. I think uh, maybe similar way that there is no specific any other things.
Okay. They have some program where one credit course is covered by industry people. So maybe you are connected there in that program only.
Yeah, that could be also an option.
Mm-hmm. So
It
anyone,
because right now we are discussing about this means technical talk.
Mhm,
So after that we can interact on the
mhm,
mail.
mhm. Akash, you have some questions? Akash, are you there? Kundan,
Yes, ma'am.
do you have some questions regarding some understanding in electrical vehicle or smart LEDs, because it all involve power electronics. So I would like that you should interact and you should get
Yes,
some.
ma'am. I was curious about the charging part because that charging is the main issue in the EV that it takes time to charge the battery we use in the electric vehicle. So
Mhm,
that's the main concern in the EV. So I got the basic from this presentation, ma'am.
mhm. Actually, all of you have to do something in industry or academia after this.
Yes,
So
ma'am.
these talks are beneficial, and you should find some connects through these conferences, through these talks. So just
Yes.
not listening, you should develop the connections also.
Yes, ma'am.
Mhm.
So
So if anyone has some, Tushar, you have worked on some microcontrollers. Do you have some questions? Tushar, are you there?
Sir, I have a question on motors, related to motors.
Mhm.
Okay.
Sir, actually, my area is in power systems, so I will be related to the topic of synchronous generators and motors as well. So, sir, can we do the projects in practical way at ST Microelectronics related to motors?
Actually, ST microelectronics, yeah, we can think about it. You can share the details and we can.
Sir,
Because
Dr. Yeah.
basically, normally we are developing electronic solutions. We are not a motor manufacturers, so that will be also new area for us.
Mhm. Dr. Rashmi Agrawal is also there in attendees list. She is from YMCA. She is asking that any MOU can be signed for some trainings or internships from government institutes and ST Microelectronics, or some for some projects.
Ma'am, right? Basically, I am not the right person for that. Basically,
I know you are you are in technical team. No, you
yeah.
are not. Okay, okay. So the technical team who was there to conclude this session here.
Yes, ma'am.
So you
At
can
the end, I would
say
like to, yes, I would like to thank you, sir, on behalf of everyone present here at INDICON 2030 for sharing your words with us. Thank you so much.
Thank you. Thank you. Thanks.
Thank you, Dr. Aman. Thank you,
Thank you, ma'am.
everyone.
Thank you, sir.
Thank you.